Well, this is our first video for the semester, and in it we're going to go ahead and look at an introduction to exercise physiology and a few other things. Now, depending upon how the semester goes, we're supposed to do face-to-face classes, but there's a good chance that that may change, and so you may end up having to watch lots of videos for exercise physiology. But even in my face-to-face classes, we still do watch videos for XPhys. Now, as you can imagine from looking at this first slide, one of my interests in exercise and exercise physiology is prevention of chronic disease and maintaining health through living a nice active lifestyle. And so to a large extent, you can choose how it is you're going to age. And so you can choose to age like the woman that you see here, who's maintained a nice active lifestyle. And so you can see that she's able to still do quite a bit even in advanced years. The gentleman over here, you can see clearly is more overweight. He hasn't done quite as good a job of taking care of himself. And as a result, he needs to use a walker in order to get around. Now, you can't always fight genetics, but there is a lot that you can do to fight genetics. And so, you just have to do the best you can, and good exercise and good nutrition can do a lot for you. The other thing that I wanted to mention to you is that I did send you a packet. If you haven't completed that packet yet, I want you to pause this video right now and please go finish that thing. All right, now if you've done the packet, what I want you to do is, based on what you did there, I want you to come up with a definition for the term physical activity. Go ahead and write it down, or if you haven't yet come up with your own definition, then think of one. So pause the video and do that. All right, here is a definition that was proposed back in 1990 for physical activity, and this person said that physical activity is intentional, voluntary movement directed toward achieving an identifiable goal. And so that means that you are doing it on purpose. And so, for instance, movement during sleep, not physical activity. Okay, this is what we're going to call our operational definition, and I won't argue that it's the best possible definition of physical activity, and maybe you have some ideas about how we might modify it to make it an even stronger definition, but it's what we're going to use for the course of the semester until we do modify it. Now, notice that it does not stipulate substantial amounts of energy expenditure. It does not have to be in a sport or an exercise setting. And simply moving the body does not constitute physical activity. Movement is a necessary condition for physical activity, but it's not a sufficient condition for physical activity. And I have actually got a worksheet that I'll share with you. And in that worksheet, there are some examples of movements, and you need to decide whether or not you think each of those is physical activity or not. Another term that we need to think about is exercise. And so again, I want you to pause the video and write down your idea of a good definition for the term exercise. And here is the operational definition that we're going to use for exercise. It's a single acute bout of bodily exertion or muscular activity that requires energy expenditure greater than resting level. Now, number one, acute means right now. That's when we're doing it. Now, I know that energy expenditure greater than resting level doesn't mean a whole lot, and so you could go out for a leisurely walk, and this definition would make that exercise. Maybe you don't like that, and maybe you want us to specify some higher level of energy expenditure, and we can talk about that and see if we can't quantify what that would be. But again, this is our operational definition for exercise. The other thing about exercise is it's a stress that disrupts homeostasis. And this is a really, really, really important concept. We're going to talk more about it later on. But real quickly, what is stress? And stress is a disruption in homeostasis, but also the attempts by the body to regain homeostasis. And so again, we'll come back to that and we'll talk more about that in the next video. Now what I want you to do is pause this video, make a list of different categories of physical activity. How can we categorize physical activity? All right, you have this table and parts of it are filled in. You can go ahead and fill in the rest of it. But one category of physical activity that you're all very familiar with is sport. And so I've listed 4 different sports here. You can clearly add on to this list, so you can go ahead and add a couple if you want to. Another category of physical activity is exercise. And again, I hope that all of you are involved in exercise on a regular basis. One type of exercise is what we might refer to as training. And people who are athletes and participate in a sport, they train all the time. And different exercises that are used to do training include weightlifting, aerobic training, whether it's running or cycling or swimming, and anaerobic training. And again, that could also be running or cycling or swimming. It's just at a higher intensity. There are people who are no longer involved in sport, and they're not trying to maximize their sport performance, but they still exercise. And so maybe they're in it for their health. And again, they're trying to prevent chronic disease. And so they're doing aerobic activity, maybe jogging, again, maybe swimming, maybe cycling, maybe something else. They may be doing flexibility training, whether that's yoga or something else. And again, they should also be doing some weightlifting. Everybody should be doing some weightlifting for their health and well-being. And then a third type of exercise is what we refer to as therapy. And so many of you have been injured either through sport or some type of an accident. And so perhaps you've visited a physical therapist or an athletic trainer who has prescribed range of motion exercises or resistance band exercises or body weight exercises known as calisthenics. Or maybe even as you've progressed, you've gone to dumbbells or medicine balls or things like that. A third type or third category of exercise is what we refer to as recreation, also sometimes referred to as leisure time physical activity. And the physical activity that you do in your leisure time plays a really, really important role in your health and your well-being. And so these can include things like dance, play. Maybe you go out and play hide and seek with younger brothers and sisters, or tag, fishing and hiking. Golf could be recreation, or it could be a sport, as you well know. We have friends who are golfers on the golf team. Work is another category of physical activity. Now, my work, not so much, because I sit at a desk and make up these PowerPoint slides. That's not really physical activity, but a lot of work, and perhaps you've held a job during the summertime, which was work. Some of you may have worked in construction or landscaping or something like that. And so there are lots of things. Maybe you have been involved in moving, and so you have to load and unload trucks. Chores that you do around the house could also be physical activity: mowing, gardening, raking, things like that. We have another category, which is what's known as activities of daily living. These are sometimes referred to as ADLs. You guys don't even think about these things because they're very easy for you and it takes no effort. But as people age, as they become elderly, if they've had a stroke or something, these things may be very difficult for them. Other activities of daily living might include things like putting away the groceries. And so think of having severe shoulder arthritis and try to put groceries up on a top shelf in your cabinet. Think about what that might be like for you. And maybe you can add a couple of other ADLs to this list. And then we have what are known as developmental skills. All of you went through learning how to do these when you're infants. And again, as we age and we become elderly, we may lose some of our ability to do this. And so it's good to relearn this. And again, if a person has had a stroke, they may have to learn to walk all over again or learn to run. And so here are some categories of physical activity. You can let me know in class if you came up with a category which isn't here, and we can talk about it. And now we're going to talk about what exercise physiology is. So here we go. This is the title of the class. We've talked about exercise. You've had 2 classes in anatomy and physiology. And so write down a definition of exercise physiology. Here's a definition that comes from a popular exercise physiology textbook. And so the authors define exercise physiology as both a basic and an applied science that describes and explains and uses the body's responses and adaptations to exercise training and helps to maximize human physical potential. And again, that's what athletes are trying to do, maximize human physical potential. Well, what is a basic science? A basic science is understanding how things work. That could be a single cell. It could be an organ or an organism. So for example, understanding how energy and glucose is transferred to ATP is really basic science. Another example would be understanding how exercise affects immune cells and immune cell function. That's basic science. On the other hand, applied science is using the information from basic science to solve practical problems. And so, for instance, you might want to know what is the best protocol to increase muscular strength. And so you could design a study where you compare several different protocols and see which is most effective. The truth is that the majority of the theses that our seniors do in kinesiology would fall under applied science, Another definition is study of the acute physiological effects of exercise. Those are the responses, and now you see why response was in bold. And the physiological changes occurring as a result of training, and those are adaptations. And so acute, again, means happening right now. That's what it means. And adaptations would be due to chronic training. So training is chronic, over weeks, over months, even over years. All right, let's go ahead and define an exercise response again. So pause the video and write down the definition of an exercise response. So a response is a physiological change occurring during the bout of exercise. It's what you're doing right now. You're riding the bike, you're in the pool swimming, you're out on the soccer pitch. These changes are mediated by an increase in the activity of the sympathetic branch of the ANS, autonomic nervous system, right? See if you can list some examples of exercise responses. And so here are examples: increase heart rate, increased blood pressure, increase in both rate and depth of breathing, increase in sweating, an increase in blood concentration of epinephrine or cortisol. The bracket is my little shorthand for concentration, or an increase oxygen use as the final electron acceptor, and you know that that's symbolized as VO2. Oxygen consumption. How might you illustrate exercise response to a class if you were over at the Greencastle Middle School? And so maybe you might use a heart rate monitor and have somebody do some stepping up and down on a chair or a bench and look at how their heart rate changes as they do that. And so here you can see the heart rate response to short-term, look, it's only 15 minutes, steady state exercise. Steady state because it seems to have hit kind of a plateau. Okay, and this is a curve that you should memorize in terms of the shape of it. So many variables. Their response is to increase fairly quickly, increase a bit more slowly, and then hit a plateau of sorts. This is the steady state that you see here. And then this is the cessation of exercise, and so this is the recovery part of what's going on here. Here you can see the response of VO2 to a bout of exercise. So they start off, and you can see that they did 2 minutes of rest first and measured VO2 during rest. And then the exercise began, and so VO2 increased very rapidly, and then it increased more slowly, and then it hit the steady state. And then again, here is the cessation of the exercise, and VO2 drops very rapidly. And then lastly, here is the response of insulin. And so we're looking at the concentration of plasma insulin to a bout of exercise, 60 minutes. And you can see here that where heart rate and VO2 increased, insulin actually decreases. All right, define exercise adaptation. And so again, what you should say is, And adaptation is a physiological change seen following a program of exercise, usually at a minimum of several weeks, but quite often several months, at least 3, 4, 5 months. And so where the response is acute, the adaptation is chronic change. Go ahead and list some examples of adaptations that you would expect. And so you might expect to see a decrease in resting and exercise heart rate. You know that when you exercise, your heart rate doesn't go as high when you're in shape. The same is true of both resting and exercise blood pressure. We get decreases in blood pressure. We get decreases in both the rate and depth of breathing, and I hope you remember that that's what's known as minute ventilation, expressed in liters per minute. We get increases in muscular strength, and initially that's due to a better ability to activate the muscle. But after a while, you start to get increases in contractile protein that makes muscle stronger. And then you can also, if you do the right type of training over a long enough period of time, you can get an increase in number and size of mitochondria. And so that can happen as well. And then we can also get changes in oxygen consumption. And so if you exercise over a long enough period of time, you actually get an increase in the maximum oxygen consumption. All right, how could you illustrate adaptations to exercise? And as you can imagine from what you've seen so far, I'm going to expect you to be able to look at lots and lots of different graphs and interpret them, tell me what they mean, but I'm also going to expect you to be able to create these graphs on your own. And so here you can see the heart rate response to exercise in white, that's the pre-training, and then you can see it in blue, that's the post-training. Now, on both days, the person did exactly the same amount of work. And so if we had them running on the treadmill at 7 miles per hour pre-training, that's exactly what they did post-training. And here you can see that the heart rate goes up a bit faster. The plateau is at a slightly lower level. And then you can see that recovery heart rate is also faster after a person has trained. And then here we can see similar data for oxygen consumption. And so the green is the pre-training and the white is the post-training. And you can see the same type of thing. VO2 goes up faster when you're trained, and you actually are a little bit more efficient. And so even though you're doing the same amount of work, you don't need to use quite as much oxygen in order to accomplish that. So just to reiterate, if pre-training the person was running at 7 miles per hour, post-training they're also running at 7 miles per hour. They're doing the same amount of work. Okay, now pause the video and remind yourself, what is the difference between exercise and exercise training? And what you should have said, that exercise is acute. It's what's happening right now as you're running on the treadmill. Your heart rate has gone up to 140 beats per minute. Exercise training, on the other hand, is doing this 5, 6, 7 days a week over 3 months. All right. Now here you can also see an adaptation when we look at this. Now we're looking at VO2. Why is it going up like this? And so when you look at the x-axis, what is the variable? And so now you can see that we're gradually making the person run faster and faster and faster. We started them at 6 miles per hour, but they end up at somewhere around 13 to 17 miles per hour, depending upon whether they're trained or untrained. And so that's what you see going on here. Now, what I want you to do is I want you to look at what's the increase in VO2 max that was achieved because of the training. And a good way to look at that is actually to express it as a percent. And so VO2 max post-training was 58 mLs per kg per minute. Pre-training, it was 45 mLs per kg per minute. So we take 58 minus 45. We divide it by the pre-training value, 45, and then multiply by 100 in order to express that as a percent. And you can see there was a 28.8% increase here, which is really a lot. That tells me that this person was probably confined to some bed rest. They were sick, they were injured. Once they got better, they started to train again. And so that's why their VO2 increased by that amount. Normally, we would only expect an increase of 20% or less. Again, How is exercise different from exercise training? Which one is chronic? Which one is acute? Exercise is acute and exercise training is chronic. Now we're going to look at the different categories of exercise, and we've already talked about 2 of them. And so again, here what we have is we have short term, only 15, 16 minutes, steady state because it hits a plateau. And so that's what we see here. On the other hand, look at this one. Now it's over 60 minutes of exercise. It's no longer short term. And so that's the major difference that you see here between these 2 things. Heart rate is going up slightly higher, and so maybe they're running at a faster speed as well. Again, as I said, this is short-term steady-state exercise. Memorize the shape of this curve. Memorize it. Know it by Friday, or maybe know it by Monday when you get to class. Here you can see that it looks similar to begin with. We've got a rapid increase in heart rate, a little bit more slow increase in heart rate, and it seems to hit a plateau, but then at about 35 minutes or so, it starts to move up again. And this is what's referred to as drift, and since it's going up, we call it positive drift. We refer to this as prolonged exercise because the person was doing continuous exercise for more than 35 minutes. And I will just mention this now. We'll talk about it again later. Some variables will show negative drift. And then lastly, look at this one. What's going on here? Why is it that heart rate is continuing to go up and up and up and up all the way to the end of the exercise? And what you should say is, well, it's because it's incremental exercise and we're increasing the workload every couple of minutes. And so again, if they're on the treadmill, perhaps what we're doing is we increase the speed by 1 or 2 miles per hour every couple of minutes, or we increase the grade at which they're running. And so that's what's going on there. 3 types of exercise. Short-term steady state. Notice that that's one type. Prolonged, incremental. And those are the 3 types that we'll talk about throughout the semester. Now I want you to go ahead and look at this and try to understand what it is that it's showing. And so again, remember, balance of inputs and outputs, right? Balance of inputs and outputs. Key concept in physiology, core concept that we have here. And so I want you to diagram physiological change that might occur with an imbalance on one side or the other. Pick your side, I don't really care. And so pause the video and do that. Okay, and so maybe if you said we're going to have the imbalances on the fluid intake side, water increases, the osmoreceptors are actually going to sense that the body fluids are becoming more dilute. And that information gets sent to your hypothalamus. Hypothalamus sends a command to say, okay, we want less ADH. Less ADH, so we're going to have a higher volume of urine, try to get rid of the excess water, and return us back to EU hydration. EU means normal. So the prefix EU means normal hydration. On the other hand, maybe what you said is we're going to have a water decrease. The person is sweating too much and they peed a lot and they're not taking in enough fluid. So now we've got a decrease in total body water. Now the osmoreceptors are sensing that body water is more concentrated than it should be, and the hypothalamus signals the posterior pituitary that we need more ADH, and that's going to make the kidneys reabsorb as much water as possible. It's also going to make you thirsty, and the hope is that then you'll go ahead and you'll take in more fluid and get us again back to a euhydrated state. So thinking about this, what is hydration status in homeostatic terms? And I hope what you said is, I hope you said, oh, it's a regulated variable. And again, I want you to go ahead, pause the video, write down at least 3 other regulated variables. Maybe you can go ahead and write down even more than that. Okay, again, these regulated variables are all about homeostasis. homeostasis. And homeostasis, as you know, is the maintenance of a relatively constant, not absolutely constant, or relatively unchanging internal environment. You know, the truth is that we actually have to keep things within a narrow normal range, not constant, fluctuating within this normal range. Okay? And then here is a table of regulated variables. All of these things are regulated variables. And so we just finished talking about hydration, but blood pressure, blood glucose, core temp, blood acidity, arterial partial pressure of O2, arterial partial pressure of CO2, these levels of ions that are essential to you. All of these are regulated variables. Now, you might remember from anatomy and physiology, if you took it with me, that I told you there, some books screw it up and they give you things and say, oh, this is a regulated variable. No. See if you can come up with some examples of variables that change that aren't regulated. And so I hope that you jumped all over heart rate. Oh, heart rate changes, especially when you exercise, not a regulated variable. And then the plasma concentration of epinephrine and other hormones, cortisol, glucagon, insulin, those are not regulated variables, even though they do move up and down in response to stuff. What does your body use to maintain homeostasis? Well, I hope that what you said, you look at the diagram down here, and that's kind of a hint for you. It uses a biological control system, which again we sometimes just refer to as a BCS. What are the parts of a BCS? Well, again, we've already kind of indicated some of the parts. Part number one is the receptor. And the receptor is monitoring the variable that we're looking at. And again, it's looking to see if whatever it is moving far away and sending information to the integrating center. The first job of the integrating center is to look at this and say, is the variable increasing? Is the variable decreasing? The second job of the integrating center is to send a command to the effector organ or the effector organs to try and correct it. And so if things are changing, the effector organs are going to be activated to try and get us back to where we need to be. Okay? And so go ahead and give an example of a control system. Here you can see an example of an engineering system. And this is kind of ubiquitous. It's used in all physiology books, all A&P books, and it's not the greatest, but you know, you do have a thermostat which can tell when the temperature is going up, and it will turn on the effector, which in this case is the air conditioner, and that helps to bring the temperature back down again. All right, that brings us to the end of the first half of the Intro to Exercise Physiology PowerPoint, and in the next video we'll cover the second half. You probably noticed that I gave you both halves all in one PowerPoint. And so again, that brings us to the end. Okay? And so you can go ahead and do this on your own. I suppose I did forget a couple of things here. And so first of all, does the presence of a biological control system mean a variable is a regulated variable? And again, the answer is no, not always. Sometimes yes, but not always.